Hi everyone, so in today's video we are going to solve this question: remove kth node from the end of the linked list. So let me explain you the question and then we will discuss about the possible solution. So these are the nodes. So 1 2 3 4 5 6 7 8 9 and 10. So there are total 10 nodes, right? So basically the length of my linked list is 10. So this is length of linked list is basically 10. Right now what I want to say is, so first let us discuss, before removing, let us try to find the kth node. Okay, so if you are able to find the kth node from the end, then we can also remove it. So first let us discuss how we can find the kth node. So for example, let's say the value of k is 4. So what is the fourth node from the end? So this is the first node from the end, this is the second last node, this is the third, and this is the fourth. So basically we want to find this node. Okay, after finding this node we will remove. So the original question is removal, but first let us discuss how we can find this node, right? So how we can find this node? So there is one way. So the first way is basically, it is very simple. So first find out the length. Okay, so what is the length? So length is, let's say it is L, right? So, or let's say the length is n. So n is the total number of nodes present in our linked list. So the value of n is 10. And after finding out the n, so, and let's say this is k. So k is basically the kth node from the end. So kth node from end is basically n minus k plus 1th node from front. Okay, so let's try to evaluate what I am saying. So I want to say that kth node from the end is same as n minus k plus 1th node from the front. Okay, so let's see whether this formula is basically correct or not. So this is the fourth node. Okay, so this is the value of k is 4, so this is the fourth node from the end. So let's apply the formula. So 10 minus 4 plus 1, so this is 7. So this should be 7th node from the starting. Okay, so first node, second, third, fourth, 5, 6th, and yes, 7th. So this is 7th node from the front. So that means this formula is correct. So it is same as kth node from end is same as n minus k plus 1th node from front. Now how did I get to this formula? So basically this is simple maths formula, right? This is simple maths, or if you don't know the formula, then it is, I mean, you can just observe and you can derive this formula. Okay, so this is very simple maths. If you will observe, you can easily reach at this formula. So how we can find? So it is very simple. The first approach says, step 1, find the length of the linked list. We know how to find the length of the linked list. Just iterate over the complete linked list and maintain a counter. So after step 1, what is step 2? So step 2 is basically calculate. What you will calculate? So you will calculate this value, n minus k plus 1. So you know the value of n. So n is basically the length, total number of nodes present. K is given by the user, and this. So after calculating this formula, let's say the value of k is 4, and let's consider this example only, and the value of n is 10. So this formula will came out to be 7, right? So how many iterations you want to do? So you have to do, let's say this value is basically I. Okay, so you will do I minus 1 iterations. I minus 1 iteration, basically you will do 6 jumps. You will do 6 jumps. Let's see. So this is the first jump, this is the second jump, third jump, fourth jump, fifth jump, and this is the sixth jump. Okay, so we are doing 6 jumps. So after doing 6 jumps, you will reach at this node, and that's how we will be able to find the node, so that's how we will be able to find this node. Okay, so in this approach, what is the time complexity and the space complexity? Time complexity is big O of n. We are just finding out the length and iterating over the linked list again, right? And again the space complexity is constant. We are using constant extra space. Okay, so we are traversing the linked list 2 times. First, when we are finding out the length, and second, when we are finding out the node. So we are doing 2 traversals, right? But the question is, you have to do only 1 traversal. Only 1 traversal is allowed. Now the question is how we can solve this question. when only one traversal is allowed. So let's see. So it is very simple problem what we will do. So let's take this example only. 10 nodes, the value of k is 4. Okay, so we have 10 nodes, first, second, third, fourth, fifth, sixth, seventh, eighth, ninth and 10th. So the value of n, so total nodes are 10, k is 4. So k is 4 means this is the first node from the end, second node from the end, third node from the end and the fourth node. So I want to find this node, right? Okay, so only one traversal is allowed. We can traverse over the linked list only once and not twice. Okay, that means the above approach will not work. Okay, so one traversal is allowed. So the approach is basically take 2 pointers. Take 2 pointers. So let's call it pointer 1. Okay, this is your pointer 1 and this is your pointer 2. Okay, so the name of the first pointer is 1, the name of the second pointer is 2. Fine. Now what you will do is basically there is a trick involved here. So what we will do, the value of k is 4, so maintain the distance between 1 and 2 pointer by 4. So that means make, so 2 pointer will jump 4 steps. Okay, so take 4 steps. So 2 will come here, first step, second step, third step and fourth step. So this is your position of 2. So I am repeating myself again. So initially 1 is present here, 2 is also present at the head. Okay, so initially this is my head of the linked list. So 1 and 2 are present at the head of the linked list. Now the value of k is 4. So what we will do, so take pointer number 2 and it will take k jumps. Okay, it will take k jumps. Now this is 2. Okay, after taking k jumps, the value of k is 4 and this is 1. How much is the difference between 1 and 2? So 1, 2, 3 and 4. So the difference between 1 and 2 is basically 4 nodes, right? So the difference is 4 nodes. Perfect. Now what we will do, so 1 will move ahead in this direction, 2 will move ahead in this direction. Okay, so this is null. So the idea is when 2 will reach at this point, so when 2 will reach at null, where will be 1 present? So 1 will present 4 nodes back. So that means, so first node, second node, third node and fourth node. So 1 will be present at this node when 2 will reach null. Okay, and 1 means, so this is the node that we want to find. So the steps is very simple. So what is the first step? Take 2 pointers, 1 and 2. Initially they will be present at the head. Now the second step is basically the 2 pointer will make k jumps. The 2 pointer will make k jumps, and now the difference between the pointer 2 and pointer 1 is basically of k nodes. Fine. Now what we will do, so move 1 and 2 simultaneously. 1 and 2 will simultaneously move in forward direction, right? So we have single linked list, we can only move in the forward direction. So both will move in the forward direction. And step number 4, when 2 will reach null, so 1 will reach the node that we want to find, basically the desired node. So let's take this example only. So 1 is here and 2 is here. Okay, so let's do one thing. Let's dry run this logic on this example, right? So we have 10 nodes. So this is node 1, node 2, node 3, 4, 5, 6, 7, 8, 9 and 10, and finally we have null. So where is 1 present? So 1 and 2 initially they both are at head. Okay, so this is my 1 and this is my 2. Now 2 will do k jumps and the value of k is 4. Okay, so first jump, second jump, third jump and fourth jump. So this is the position of 2. Fine. Now both 1 and 2 will move forward. Okay, so let's move them forward simultaneously. So remove t. So this is 2. Okay, and remove this. Both will move forward. So 2 is moving forward, 1 is moving forward, 2 is moving forward, 1 is moving forward, 2 is moving forward and 1 is moving forward, 2 is moving forward and 1 is moving forward. So 2 reaches null, 2 is moving forward and 1 is moving forward. Now as soon as your 2 reaches null, So 1 will reach at this node. And what is this node? So this is the last node, second last node, third last node, and the fourth node from the end. And this is the node that we want to find out. Okay, so this is our desired node. So finally, when 2 reaches null, 1 will be at the desired node. So finally what I will do, so I will return 1. And why this code is working? Because the difference between 2 and 1 is basically of k nodes. So that's why when 2 will reach the null, 1 will be k nodes behind. Okay, 1 will be k nodes behind, and that's how we will be able to find the kth node from the end. And how much traversal? So we are just simply traversing on the linked list one time. Okay, so this is only one traversal. We are not traversing the linked list 2 times, we are traversing the linked list only one time. So again, the time complexity is big O of n, and the space complexity is also big O of 1. So space is constant. So the time complexity of this method and the previous method both are same, but the only difference is we are doing only one traversal. In the length approach, finding out the length approach, there were 2 traversal. Okay, so here we are using one traversal. Now let's come back to the original question. So the original question is not to find out. The original question is not to find out the kth node from the end. The original question is to remove the kth node from the end. Okay, so the original question is we have to remove the kth node from the end, and we have to do this in one traversal only. So let's see how we can do this. So we just have to modify this approach. So how we can modify this approach? This is 1. So 1 is present at the desired node. Okay, so I want to remove this node. So if you want to delete one node, so suppose this is your linked list. If you want to delete this node, that means I have to stop at this node. So I have to stop at this node so that I can do something like this, right? So I have to stop one node before the desired node. If this is the node to be deleted, then I have to stop one node before the node which has to be deleted, right? So that means we will stop when t reaches null. No, this is not. We will stop when t reaches the last node. T is 2. Okay, so when 2 will reach the last node, so 1 will be present at this node. Okay, one node behind the node to be deleted, and then we can do something like this. Okay, so this node will get deleted, right? So we'll just modify this. So what we have to do? So first step will remain same, second step remains same, third step will remain same. The fourth step will be when 2 will reach the last node. And what is the condition of last node? So 2 arrow next will be null. So when 2 will reach the last node, so 1 will reach one node before the desired node. So 1 will reach here. Okay, and then what we can do? So we can do 1 arrow next is basically next of 1, right? We can make this connection, right? So this node will be removed from the linked list. So we have to modify our solution, right? Okay, so we can do this, and we can solve this question in only one traversal. Okay, so similarly you can update your length approach also. Okay, you can update your length approach. So what was our length approach? So length approach was first find out the length. Obviously we have to find out the length, and then we have to calculate this formula n minus k plus 1. Yes, then we were doing I minus 1 iterations. We were doing 6 jumps to reach the desired node. So here what we will do, instead of I minus 1 iterations, we will do I minus 2 iterations. So we will do 5 jumps so that we can stop one node before the node which is to be deleted. We want to delete this node, right? So I will stop at this node, and then I will make this connection. I minus 2 iterations. So we will do 5 jumps, right? So you can modify the code. Okay, so let's write the code for removing kth node from the end of the linked list, and this is our logic. Okay, so this is our final logic. Take 2 pointers, 1 and 2, both are head. 2 will make k jumps. 1 and 2 will both move in the forward direction, and this is the stopping criteria. Okay, so this is the stopping criteria. When the next of 2 becomes null, that means the last node. So 1 will stop one node before the node which is to be deleted, and then we will do this. Okay, so this question is actually present on lead code, right? So this is the question: remove the nth node from the end of the linked list. And if you'll see the question, so it is saying here you have to do this question in one pass. So this one pass means only one traversal, right? So we have to do this question one traversal. Okay, so this is the example 1 2 3 4 5. The value of n is 2, so that means I have to remove the node 4. So this is the updated linked list 1 2 3 and 5. So instead of n, let's rename the variable k. Okay, so I want to delete the kth node. So let me write the step so that you can understand what you have to do. So I will take two pointers, so pointer 1 and 2. Initially both will be present at the head of the linked list. Fine, so this is step 1. Step 2 is basically the pointer 2 will move k jumps ahead. It will do k jumps, so that the difference between first and second node is of k jumps, right? So the difference between 2 minus 1, this is of k, right? So third is 1 and 2 will move in forward direction simultaneously. So 1 and 2 move forward. Okay, and what is the stopping criteria of moving forward? So the stopping criteria is when 2 will reach the last node. So when 2 arrow next is basically null. So when 2 will reach the last node, so this is the condition for reaching the last node, then I will stop. Okay, so this is the stopping condition, and after that, so this will be the condition. Okay, so this is 1 and this is the node which we want to delete. So I will make a connection like this. So I will do 1, the next of 1 is simply the next of 1, and finally what we will do, so if you will see, the return type of the function is list node star. I have to return the head of the linked list, so finally we will return the head. Okay, so this is our approach, and the time complexity discussed many times is linear, and we are doing only one pass. Okay, one passes. So let's see, let's write the code, right? So we have to make two pointers first. So list node star 1 is present at head, and similarly the second pointer list node star 2, so this is also present at head. Okay, so how many jumps? K jumps. So we have to do k jumps. So while k minus minus, so this loop will run k times. Okay, so I have to do k jumps, right? So this loop will run k jumps. So this loop will run, so this loop will run k times. And what we have to do, so 2 equals next of 2. So 2 is moving forward, correct? And now 1 and 2 will both move forward. Okay, and what is the stopping criteria? 2 arrow next is null. So we have to reach the last node. So while 2 arrow next is not equals to null, so this is my stopping criteria, and both will move forward. So 1 equals next of 1 and 2 equals next of 2. Perfect. And finally, what we will do, so we will delete the node. We will delete the kth node from end. Okay, so let's delete the node. So for deleting the node, 1 arrow next is next of 1. And after deleting the node, what we have to do, so I have to return the head of the linked list. Okay, so I have to return the head, so I am returning the head. Okay, so I think we did everything fine. So I think this code should work, but there is one problem with this code. So let me run this code and then I will show you what is the problem. So our code is running fine, but when we will submit this code, it will definitely give us error, and I will tell you why the error will come. There is one simple case that we are not considering. So our code is working. Yes, so what we are getting, so we are getting runtime error. Okay, so what we are doing here is, so this undefined behavior means, so this is runtime error. And by runtime error, you can see, so at this line, what you are doing, so you are accessing 2 arrow next. Okay, and what if 2 is null? So what if 2 is null? You are doing null arrow next, and obviously this will give you runtime error. Okay, so in what situation this 2 will be null? So consider one situation. So let's say there are 5 nodes in your linked list, or let's say there are only 4 nodes. So there are 4 nodes in your linked list, right? And let's say you want to delete the 4th node from end. Delete 4th node from end. So this is the first node from the end, this is the second node from the end, this is the third node from the end, and this is the 4th node from the end. So that means I want to delete the first node. Okay, if you apply the formula n minus k plus 1, so n is 4, k is also 4, 4 minus 4 plus 1, so that means the first node from the beginning. So I want to delete the first node from the beginning, and now execute our code. So what we are doing, so 1 and 2 is present here, so this is your 1 and this is also your 2, right? Then what you are doing, so while k minus minus, how many times? So 4 times this loop will run. So 1 time, second time, third time, and the 4th time. So this is null, right? So basically your 2 is pointing towards null. So your 2 is pointing towards null, and then you are doing null arrow next. So in this situation, the situation in which the length of the linked list, so if the length of the linked list is same as the node, the value of k, then in that case your 2 will become null and you will get runtime error. Now how to resolve this problem? Okay, so think how we can solve this problem. What condition we should add? So we can simply write a condition here that if basically the pointer 2 becomes null. So if 2 becomes null, that means k becomes equals to the length of the linked list. Okay, and then in that case what we can do, so we have to delete the head. Okay, so we have to delete the first node. So in that case we have to delete the first node, so we can simply write return 1 arrow next. Okay, 1 is pointing towards the first node, so we can return 1 arrow next. Fine, so let's do that. Let me erase the screen. Okay, so check first that if basically 2 becomes null, if 2 is null, so when this condition will be, so when basically the length of linked list is basically equals to the value of k. Okay, so in that case what you have to do, so you have to delete the head node. Basically you have to delete the first node, right? So for deleting the first node, what you can write 1 arrow next. So we can return 1 arrow next. Okay, so I am returning 1 arrow next. The return type of the function is list node star. Okay, so now I think our code will work. Okay, so one thing here is, so we are not deleting the node, so our code is basically suffering from memory leak problem, but that's fine. Why it is fine? Because we are submitting our code on an online judge. It's a website. Okay, so it's okay. Okay, if you want you can handle the memory leak. Similarly we have memory leak here also. Okay, it's your choice. If you want to handle the memory leak you can handle, otherwise it's also fine. So let's submit our code. Okay, so now this time our code is working for all the test cases, success, and our code is 92.72% faster than all the C++ solution. So that's how our code is working. And one last time. Okay, so we are solving this question in only one pass. Our time complexity is linear and space complexity is constant, and we are solving this question in one pass. And you don't need to worry about the value of n is basically k. Okay, so you don't need to worry about k. K will always be valid. So you do not have to check conditions like this if k is greater than the length of the linked list. So there is no need to write conditions like this because it is given in the question that the k is going to be valid. So if you have any doubt in this question you can ask me. Okay, thank you.